black X. And then a word will show up on half of the screen. So if it shows up on this half of the screen, which half of his brain is seeing it?
Right.
Awesome. You guys are good. Awesome. So the right half of his brain is seeing it. And something that's true in 95% of you kids in this room is that all of the language parts, all of the talking and the understanding language is on the left side of your brain. Unless anyone here left-handed? Yeah, you run the risk. It could be on the right side of your brain. But in right-handed people, it's always on the left side of your brain.
Backwards.
And so the amazing part about this guy is that he couldn't, he saw this word key, but when you asked him, what did you see, the talking part of his brain wasn't connected to the part of his brain that had seen it, and so he couldn't tell you what he saw. He thought he hadn't seen anything. But then if you asked his left hand to reach behind this screen and pick out one of several objects, this is another thing that's crossed over. So your left hand is controlled by the right side of your brain. So as you remember, he saw the word with the right side of his brain, but the left side of his brain, his talking part, couldn't tell you about it because it wasn't connected to the right side. But his left hand is still controlled by the right side of his brain. And his left hand can reliably pick out the key from the objects there. So even though he, as a person, would say to you, I don't know why I picked the key, he can reliably pick it out every time. So what it shows you is that your brain isn't like one little man pulling some levers, but it's a whole bunch of parts that usually work together really well, and then it all makes sense, but sometimes doesn't work together really well. And then you end up with things like this. Split brain. It's fascinating. All right, so the last part on this picture is called the cerebellum, which means little brain or baby brain. And it's really small. It takes up only 10% of the brain area, but it has half of the neurons in your brain, so it must be really important. And it is really important. And I don't know if you've ever seen, like in a movie or something, someone who's had too much to drink and they kind of stumble around a little bit, or they try to do this to the cop and they can't do this, like finger to the nose. That's because of their cerebellum. So alcohol selectively seems to interfere with your cerebellar function. And what the cerebellum therefore is for is coordinating all your movements. So if you remember the primary motor strip up here, okay, yeah, so this part of your brain plans things out, the frontal cortex. Your primary motor strip says, all right, let's do it. And then this part of your brain, the cerebellum, puts it together. Because I don't know if you guys have ever seen like babies, and they're just kind of like twitching, and they can't really get themselves together. It's the same kind of thing. The cerebellum is for putting together all the fine movements. Like when I move my arm out, I have to flex my triceps and relax my biceps, and I have to stabilize the shoulder so it doesn't fall down. There are all these things that have to go together, and that's handled by your cerebellum. And it's the same thing for standing up. There are a whole bunch of muscles all up and down your back and in your pelvis that do control your balance, and that's all in your cerebellum too. Your little brain, cerebellum. All right. The last parts of the brain I'm going to tell you about are the amygdala and the hippocampus. And they're buried. So remember I said the cortex is like a sheet of newspaper that's all crinkled up, and it sits on the outside, and then there's a whole bunch of stuff tucked away in the middle. And your hippocampus and amygdala are some of that stuff. The hippocampus is the part of your brain that controls memory. So when I told you about those people who had their temporal lobes taken off for epilepsy, and they couldn't remember anything, what was actually happening is that the hippocampus, which is tucked inside of your temporal lobe, was being damaged. So this is the thing that gives you the 51st states, is your hippocampus with the part. The amygdala is really tightly connected to the hippocampus, and its function was determined by this other really fascinating syndrome. This lady has, or lots of people have it. It's called, you're not going to look up. It's a fascinating syndrome, and what you get is that part of your brain like hardens up like a rock, so it gets a whole bunch of calcium deposited in it, and it stops working. And what happens when you lose your amygdalas on both sides is that you get really friendly and really disinhibited. So you'll like hug random people, or you'll just like you walk up to strangers and say hi. And are you guys disinhibited? She's disinhibited. It's okay to hug people. It's normal to hug people. I don't want to discourage hugging.
I don't have that.
All right, we're going to hug at the end of class. All right. But if you don't have your amygdala, the amygdala is the thing that makes, and it also makes, without your amygdala, you can't make those flash memories. Like if you see someone get hit by a car, it's like this terrifying memory that has all this emotional content wrapped up in it, then the reason that you remember it and you can remember that moment forever is because of your amygdala. So your amygdala is part of memory, and it's those like really emotional memories, and your hippocampus is all your other memories, the memories that you think of as memories. Like everything you're going to remember from this lecture. That's right.
Okay.
All right, so that's the brain. And this is the spinal cord. It's the part that dangles off the back. Oh, this is I'm going to skip this movie. It's not that cool. It's a cat walking. It just walks. It's not exciting. But what's exciting about it is the part you can't see. So this cat has a spinal cord injury. They severed its spinal cord up at the top so that it could still breathe. So they severed it in a good place so it can still breathe and still be alive, but it can't control its legs at all. So it has a terrible spinal cord injury. But the amazing thing about this cat is that they put it on a treadmill and it will walk like any other cat. And if you speed up the treadmill, it will like start to run like any other cat. And the reason for that is that even though your brain is so fancy and clever, there's a whole lot of stuff that we do every day that lives below that in the spinal cord. So things like walking, you don't need a brain for, technically. I mean, someone would have to hold you up to balance you because it's a little more complex than that. But another place you can see this is if you ever play with a little kid. So little kids, like when they're 1 month old, they're just floppy and ridiculous. And they obviously can't control their muscles at all. But if you put them by the side of something, so their foot is right on the edge.
It won't be straight.
And then, well, yeah, so they'll either they're stiff like this and they'll support their weight, which is kind of funny, and then that goes away and they get really floppy. But the other thing you can do is put them near the edge of something and touch the top of their foot to the edge of the table, and they'll step up. Because even though their brain can't control their muscles yet, their spinal cord, all those little reflexes are already built. And that's, oh, no it's not. Sorry. Does anyone have any questions? You guys aren't asking a lot of questions.
Because you're so good at teaching.
Nice.
Yes.
All right, so your spinal cord is this little thing that runs from, like I said, right about where your ear is, down to the kind of back of your lower back, middle to lower back. And it's as thick as your finger. That's why I put the finger there for it. So it's this little tiny guy, and yet it's so important for everything you do. Be good to it. All right. And, oh yeah, this is important. So everything in your brain is gray matter. Have you ever heard the phrase like your gray matter?
Yeah.
So your brain is made up of 2 colors. Like before they knew much about brains, they knew that you could cut it open and it was gray around the outside and white in the middle. And so they came up with the terms gray matter and white matter.
Clever.
And
Creative.
what we learn now that we're a little bit more in depth, is that the gray matter is all of the cells, so the neuron cells, and then the white matter is all of the connections between them. So it's all the wiring. And your spinal cord has that too. It has gray matter in the middle, which is all the, oh no, other way around. No, that's right. Gray matter in the middle, which is the cells that control all your muscles, and the nerves. Oh, what's that?
I was talking myself, but I said, so what make it pink? You know, I'm with blood or something.
Yeah, it's not really gray. You guys are going to do a dissection of our brain. It's all kind of mushy brown, actually. But they call it gray matter and white matter. All right, and it's the same thing as the brain. And these are some other words that you can look up if you're really bored. This is, like I told you, the whole outside of the brain is wrinkly, and there's things called gyri, and those are the lumpy parts that stick up, and they call so hills and valleys, they call them gyri and sulci instead, so it sounds fancy. All right, and like someone said at the beginning, one of the cool things that the nervous system does for you is reflexes. Has everyone been whacked with a reflex hammer before?
Yeah.
Yeah, it's pretty fun. Huh?
No.
If you haven't been, come up afterwards and I'll whack you. All right, so the way this works is you sit, if you're sitting somewhere and your leg is dangling and someone whacks you right below the knee, there are special sensors in your muscles that can tell when your muscle is stretching. And the reason you have these is that if you close your eyes, you can touch your nose, right? Everybody?
Yeah.
All right. And the reason you can do that is that, or you can do something more complex, like you could spell your name in the air. But don't do that, because you'll poke somebody. But the reason you can do that is that your muscles have nerves in them too. So you have nerves that control your muscles, and then you have nerves that listen to your muscles and ask your muscles where they are. So the reason that you can close your eyes and walk across a room is that you have all these little stretch receptors in your muscles that are telling your brain if your leg is flexed or straight, and if you're falling over. It's keeping track of all that stuff. Yeah.
So when a person becomes blind, does that part of their body become stronger or something?
Yeah. Yeah. Oh, that's really cool too. So blind people, since you have that whole big part at the back that's just vision, blind people can remap. Your brain is kind of changeable, and so a blind person, if you stuck electrodes around there, they wouldn't obviously be seeing spots, but they still tend to map out their world. So I told you that the occipital cortex, if you poke here and you poke a little bit above that, it'll be 2 dots in your vision. And in a blind person, you get something kind of similar in that they tend to represent the world spatially. So they obviously don't have vision, but they'll still, like if you snapped your fingers here and you snapped them down there, that's the kind of stuff they're putting back there to like fill in. And they're also using all that proprioception is what this is called, knowing where your muscles is. Muscles is nice. Muscles are knowing where your muscles are. So the other cool thing. Blind people are cool, but cooler than that is people who have an amputation, as far as neurologically cooler.
Don't they still feel it?
So yeah, so if you remember, what's the homunculus? Anybody?
Little man.
That's right. So you have this strip that's supposed to do all your sensation, and what if suddenly you don't have your leg? What does that part of your brain do? And what usually happens is that nearby thing, so remember the leg is at the top. And so if you lost your leg, what was right beside the leg was the hip and then the arm and the trunk, yeah. So what happens is you start to feel things, you feel them as though they're in your leg, but they're actually in your arm. So you kind of remap, so if someone were touching you here, you might say, quit poking my leg, even though if you look down, you don't have a leg. And it's worse than that because these people can also get what's called phantom pain. So they'll have pain in their leg, which isn't there. So there's nothing you can do about it because there's nothing to fix. But this is amazing. All right, this is another cool note. I just looked when I started. How much time do I have?
You're fine.
Okay.
This class now over to 10:43. This is 80.
Yeah.
So this is so cool. Okay, so people who've lost their arm. There's this guy out in LA who does like a Nova special, so you can probably find it on YouTube. His name is Ramachandran, which is awesome. And these people are missing an arm, okay? So they have wicked pain in their right arm, but their right arm isn't there. And what he did was he put a mirror right in front of them.
They did that on
they did that on House.
Yeah. See, I was just taking
Keep
over.
explaining it. I
He
didn't
stuck
see
his
it.
hand in there and he said open it and it was cool.
Yeah. So
What
this is the
happened?
cool part. Everybody, watch House first of all. Remember what they
Watch House.
They put a mirror here, so what you see is your left arm, because you can see it, you have a left arm. And then in the mirror you see what looks like a right arm, because it looks like a left arm flipped over and you don't have a right arm. Is everybody get that?
Yeah.
Okay, and so then you do things with your left arm to kind of like prove to your brain, oh, my left arm is okay. But since your brain is also seeing this mirror image that it thinks is your right arm, your brain says, oh, my right arm is okay. So you can get rid of some of this phantom pain, this pain from a limb that's not there, just by kind of showing your brain that it's all right. You guys get that?
Yeah.
Can you still do that
With an arm? Yeah, they're you can what's that? Like if you took a stick in your hand. Is that a good example? It's kind of similar. Okay, so if you took a stick in your hand and you were poking along a wall. Have you ever used a tool enough that it feels like an extension of yourself?
No.
Yes.
No, yeah. So you're like,
Is that your cell phone?
Oh yeah.
yeah, for instance. Your body can kind of remap you have this image of self that's, that kind of is where your boundaries are, where your arms and legs are, that's from these proprioceptors, but you can remap it if you put, okay, how about this? If you have a peg leg. So you're a pirate with your peg leg, and yet when you tap on the ground, you feel like you're tapping on the ground. When you're touching something, that's not a really good example. You remap it.
Prosthetic leg.
Yeah, you remap it up. You can remap to include other things.
So you saying like if your leg is amputated and you so used to not having that leg, it's gonna